Hey, I am going to show you how to design decoder stages for, I don't know, processors, basically, a little computer. If we take the counter machine as an example, so we've got three instructions: increment, decrement, and jump if R0 is not zero. So let's explain each of these instructions. So increment takes a register and increments that register. Decrement takes a register and decrements that register. Jump, if not zero, takes an address, and if register 0 is not zero, so let me write this down. If register 0 is not equal to zero, then we assign the address to the program counter. Otherwise, we increment the program counter like usual. So this is decrement R0, or RI even, sorry, because we get to select which register we decrement. Likewise with our increment. Okay, so how do we design these things? How do we use these opcodes to instruct our machine on how to do things? Well, first you have to construct a machine that does a bit of what you want. So you have to put the logic in place to, I don't know, like add one, and you're going to have to provide signals to the arithmetic unit that tell it to either add one or decrement ones, and that will allow you to do these. And if you can pass through your values of the register, that will also allow you to do comparisons using the arithmetic unit. So if you're performing a jump not zero instruction, you want to select register 0, pass that through the arithmetic unit, and that will allow you to compare it with zero, and then you'll have some additional logic on the program counter that interprets this information and decides what to do. So we're going to look at how to decode these instructions and produce control signals for, say, the arithmetic unit, or multiplexers that switch between input registers, or demultiplexers that select between output registers. Or we're also going to look at performing conditional instructions using multiplexers. So they're really fantastic. You can just do so much with them. So a demultiplexer, let's define it. So or a multiplexer, you give it input, or an array of 4 inputs and address. That is 2. So I should specify that these are binary. The address is in binary. So the address is in binary. So we have 2 bits, and that allows us to select between the 4 inputs. It's all fairly straightforward, but the insight comes from looking at the instructions and figuring out how to generate control signals. So let me open up module sim just very quickly, just to provide a bit of context for this. I'm just going to quickly add some. Yeah, if we have a few registers and we have a multiplexer that selects between them, and we're going to need a demultiplexer to select between the outputs as well. Okay, so we've got that, and what we want to do is we want to be able to implement our increment and decrement instructions. So what we can do is we can look at each of our instructions and identify how they're unique. And if you look at the topmost bits, then you see that they're different for each instructions. They uniquely specify what instruction they are. So if I had the top 2 bits of an instruction and it was 0, 1, I'd know that that was decrement without any ambiguity. So if we feed these upper two bits into a multiplexer as the address, that will allow us to select between the inputs. And if we can select between the inputs based on what instruction we have, then we can use the multiplexer to select between control signals we want to generate. So let's see if our arithmetic control, we want that will be a multiplexer, and we need to look at our inputs. So the first input will be selected by the increment instruction, and what we want it to do, we want it to add. So if I write down the arithmetic control signals, arithmetic unit control signals, add is 0, 0, 0, subtract is 0, 1, 1, 0, and pass through is 0, 0, 1. So if I just, okay, cool. So those are our control signals. I'll just move that, probably move it over here. So we want to select addition when we're performing an increment instruction, and we select the 0th input of this multiplexer if our address is the upper two bits of the opcode. So we do that. So this performs add, and then what else? If we're performing a decrement instruction, which will be the second input of the multiplexer, 0, 1, then we want to feed the subtraction control signal to the arithmetic unit. If we're going to perform a jump, then we want to pass through the value of register 0 so we can compare its current value. So we need to hardcode 0, 0, 1. And finally, we've got this 1, 1 that doesn't correspond to an instruction, so it could literally be anything, we don't care. By default in module sim they're 0, which is absolutely fine. The point is we're not going to select that input anyway, as we're going to be feeding in our opcode, and we're going to, what we're going to do, we're going to right shift that by 2 places, bringing the 2 most significant bits down to the 2 least significant bits, and that will allow us to select our input on the multiplexer. So if I just do that over here, if I have the multiplexer, and this here is going to be our instruction, and we need to hard code these things. So as I said before, by default the multiplexer's inputs are 0, so I'm not going to bother putting this first one on. So if we're performing addition here, then we select addition on the arithmetic unit. Subtraction selects the second input of this multiplexer, which is 0, 1, 1, 0, the correct signal for subtraction, and the multiplexer feeds that signal into the arithmetic unit. So we're selecting between control signals using our instruction, and then that control signal is being fed into the arithmetic unit. Likewise, you're going to have to generate signals for this multiplexer to decide which registers to use. So if you're going to be performing an increment, then you want to select register 0 or register 1 based on the lowest bit. So that would be the lowest bit of the instruction would be your first input to the multiplexer. Likewise with decrement, as again that's working on the on register 0 or register 1. With jump not 0, you want to select register 0, as that's what you're comparing it to. Well, that's what the instruction's defined as. It checks whether R0 is not equal to 0, so we need the value of R0, so passing through that through the arithmetic unit keeps the value of R0 and doesn't break it and doesn't change it, so we don't add anything to it, hence the need for passing through. And I think that should probably give you enough intuition behind this generic design approach.